Okay, I'm using a new app today, so hopefully this quality is a little bit better. You'll just have to let me know. We're going to start section 1, 2, and we'll start out by talking about the 4 different operations. There's addition, subtraction, multiplication, and division. And you know that addition and subtraction are opposite operations, as are multiplication and division. And because of this, the properties of real numbers are going to focus on addition and multiplication. Now, we can also say that addition and subtraction are opposites. Multiplication and division are reciprocals of each other. Okay, so let's start with the properties of real numbers, the identities and inverses. And this is for all real numbers n. I mentioned that later in the year we'll get into the complex number system. So these properties don't always hold in another number system. So that's why we have to say that it's just for real numbers. Okay, the added of identity property. So when added to a number, the additive, so you can see the word add there, so it makes sense that you are adding it. And then I underlined identity. Because what happens is you add a number and the number keeps its identity. So it causes the number to keep its identity. So that's one way you can remember it. Think of add and then keeps its identity. So the additive identity of any number is 0. When you add 0 to any number, it keeps its identity. The multiplicative identity, when multiplied by a number, the multiplicative identity, again, I underlined identity, causes the number to keep its identity. So the multiplicative identity of any number is 1. So 5 times 1 is 1. 5 keeps its identity. The additive inverse property, because it's additive, we're talking about the sum. So the sum of a number and its opposite, which is the additive inverse, is always 0. So you could do negative 5 plus 5 and you end up with 0. Now the multiplicative inverse, the product of a number and its reciprocal, this time it's going to equal 1, always. So if you take 3 and you multiply it by 1/3, you're going to get 1. All right, now let's look at this table, and I need to move my paper up here. All right, so we're going to fill in some examples of a number and its additive inverse and multiplicative inverse. All right, we're starting out with the number of 1/2. So what do I add to 1/2? Move this down just a little bit so you can see the table. There we go. All right, what number do I add to 1/2 to get 0? Well, it's its opposite, so negative 1/2. And the multiplicative inverse, we just take this number and flip it. So 2 over 1. If we multiply 1/2 times 2 over 1, we're going to get 1. If we add 1/2 to negative 1/2, we're going to get 0. So that's what you need to remember for the additive inverse, always equals 0. And the multiplicative inverse of a number, when you multiply, always equals 1. All right, so let's look at the next number, which is negative 6. Additive inverse, we're just going to take the opposite, which is 6. So negative 6 and 6 will give us 0. Multiplicative inverse, we just think of it as writing this number over 1, and then you can just take the reciprocal. So that would be negative 1 over 6. The signs have to be the same because we have to end up with the number 1. So negative 6 over 1 times negative 1 over 6 will give us a positive 1. These signs have to be the same. All right, now we're going to do properties of real numbers, addition and multiplication. So for all real numbers, again, we're saying all real numbers just because that's the number system that we're in right now. Okay, we're going to start with the commutative property. Now, the commutative property, you can add or multiply real numbers in any order, and you already know that. You know a lot of these properties already. We're giving them names just to say that you can still do them, or just identify what properties they are. So I'm going to give you a hint to try to remember the commutative property. Commute means to move. So think of commutative property, the numbers or the variables move without changing the result. So let's look at the example we have over here. A plus B, you switch it around, B plus A, same thing. A times B, switch it around, same thing. So the location of the variables or the numbers, I'll just write that in there too, change their location. So let's look at what it looks like with some numbers. We can do 4 plus 3, same as 3 plus 4. They're both 7. Multiplication, 4 times 3 equals 3 times 4, both 12. Now we're going to move down to the next property, and that property is the associative property. So with the associative property, the sum or the product, so when we add or multiply, of 3 or more numbers is the same regardless of the way the numbers are arranged. So with associative, think of associate, like when you associate with different groups. The grouping will change, but the value will not on either side. So let's look at algebraically, the algebra behind it. We can group A and B and then add C to it, or we can group B and C and add A. Same thing with multiplication. We can first multiply A and B, and after we get that, we can multiply by C, or we can do BC and multiply it by A. Now notice here, the numbers or the variables are not moving, only the grouping is moving. So the grouping changes. So the parentheses change. All right, let's look at what that looks like with real numbers here. 4 plus 3 plus 6 is going to be, my numbers 4, 3, and 6 are in the same order. So here it would give me 7 plus 6, which is 13, and here it would give me 4 plus 9, which is also 13. Let's look at the multiplication example. Numbers are not moving, so it's not commutative, but the parentheses or the grouping is changing. So 4 times 3 is 12, times 6 equals 4 times 3 times 6. So this is going to be 18 here, and this is going to be 12. So those two things are equal. When we multiply 6 times 12, we're going to get 72. And when we multiply 18 by 4, we're also going to get 72. So both of these are 72. And both of these are 7. Okay, let's flip it over. Next thing we're going to talk about is the distributive property, and you've done the distributive property for years. So let's just write it out, define it, and write it out algebraically and then with numbers. So the distributive property, it says when you multiply a sum by a number, the result is the same whether you add, then multiply, or multiply each term by the number, then add. So let's look at it algebraically. What it's saying is we have A times B plus C. We're just going to distribute this. AB plus AC. And here we could add those together. But here it's just another example of the distributive property. And here it's distributing this way, which is fine. So let's look at the numbers. We have 4, and we multiply 4 times 3 to get 12. 4 times 6 to get 24. We add those two together, we end up with 36. Now, we could also add inside here, and that would give us 9, and 9 times 4 is 36. Let's go down to the next set of properties. These are properties of real numbers, addition and multiplication that are continued, again just for A and B real numbers. And we'll look at the property first. And the first property is the closure property. Now this one may seem like common sense, and you may think, well, why do you even need to use it? The reason, again, is because we will be getting into complex numbers later in the year, and not all of the complex numbers, when you do operations on them, remain in the complex number system. So the closure property basically says that the sum of or product of any two real numbers is a real number. Well, what does that mean? That means whenever you add A and B or multiply A and B, the number, the sum or the product that you get is still a real number. And everything you've worked with, not up and till now, till this year, has been in the real number system. So that might seem a little strange, but again, later in the year it might make more sense why we say we have to identify that property. Okay, so what it looks like is this. 4 plus 3 is 7. 7 is a real number. Both of those are real numbers. When we add them, we get a real number. Both of those are real numbers. When we multiply, we get a real number. All right, now we're going to move down to identify the properties. We're just going to do some examples, and then you'll do some on your own. Now, because we have addition and multiplication, I would like you to identify if it's property of addition or property of multiplication. So here's an example. We have 1 plus 2 in parentheses plus 3, and then this is what we have on the other side. Now, ask yourself, are the numbers moving? The numbers are not moving, so it can't be commutative because commutative means to move. It's not the distributive because we have the same numbers on both sides. So there are parentheses that are grouped differently. So grouping or associating with different numbers. So this one is the associative, and then I just added property of addition because we are adding. There's also a property of multiplication, so again, make sure you include those. All right. Now we're going to do another example down here. Whoops, and I think I just showed you the answer. This one, we have 1 plus 3 equals 3. And it's not the commutative. These aren't moving. It's not the associative. We don't have a grouping. So it's adding two real numbers and staying in the real number system. So that is the closure property, and it's going to be the closure property of addition. Okay, now, excuse me. Looking here, then we can see that the numbers are moving. So that means it's the commutative property, and it's the commutative property of multiplication. Then the next one we have, doesn't look like the numbers are moving or switching places. Doesn't like we're changing groupings, but what we are doing is we are distributing. So that one is a distributive property. And we're not going to put of addition or multiplication for the distributive property. That's not necessary. Okay, now it's your turn to practice those questions below.